You're tuned in for another deep dive, and today we're jumping
That's
straight
right.
into LangChain. We know you're looking to get a quick, solid handle on what this AI framework is all about, so we've gathered some key resources to get you there fast.
Yep, no wading through endless jargon, just the core stuff you need.
Exactly. We've got a mix articles on use cases, a tutorial, some community insights, ethical angles, and the official docs.
A good spread, I think. Covers the practical stuff, the how-to, the why, and even those should we.
All right, so the mission today. Pull out the key insights on LangChain. What is it? Why is everyone talking about it, That Airbyte graph showed interest spiking, and what can it actually do?
Okay, let's get right into it. Fundamentally, LangChain is about augmenting large language models, making LLMs more capable for specific tasks you give them.
So it's like giving them a toolkit, helping them go beyond just responding to a basic prompt.
Precisely. It provides structure, and a core part of that is the prompt template concept. Yes, giving the LLM clear instructions, basically. So it knows what game it's playing.
Exactly. And to see how this plays out, that Airbyte article highlighted 8 pretty solid use cases. First up, summarization.
Oh yeah, super useful. Taking huge chunks of text articles, chats, whatever, and boiling them down.
Right. But LLMs have, limits, word counts, context windows.
Yeah, you can't just feed them War and Peace and expect a perfect summary. So how does LangChain handle the really long stuff?
Well, it's clever. For shorter things, it might just use a stuff method, cram it all in. But for longer documents, it often uses map produce.
That produce, like breaking it down?
Exactly. It splits the text, summarizes the individual chunks, and then combines those summaries into one final shorter summary. It gets around the length limits that way.
That makes sense. A divide and conquer approach. The article mentioned some code examples using OpenAI and load summarized chain.
Yeah, they showed how to summarize both short and long texts. They even did it with a Paul Graham essay about startups.
Oh, interesting. What was the gist of that summary?
It pulled out themes like the positive effects of benevolence and startups that are morale, collaboration, decision-making. Also how the market values future earnings. Yeah. And, well, the authors point that good intentions are maybe undervalued early on.
Okay, cool. So it works. Next use case, chatbots. Everyone knows chatbots. How does LangChain improve them?
It gives you the building blocks for more sophisticated bots. Crucially, it helps add memory so the bot remembers the conversation.
Context. So it doesn't just forget everything you said 2 lines ago.
Right. And it uses NLP for better understanding. The article mentioned RAG, Retrieval Augmented Generation.
RAG. Right, you mentioned that. What was the other?
Retrieval Augmented Generation. It's key for making chatbots experts in specific areas, like your company's internal documents, by grounding their answers in that specific data, not just their general knowledge.
So you feed it specific info and it becomes an expert on that topic. Like Nexus GPT, was that the example?
Yeah, that was one example. They also had that kind of funny example of an unhelpful chatbot making jokes.
Huh? Yeah, what was that about?
I think that was mostly to show you can, control the bot's personality and how it responds using LangChain's prompting and memory features, even if you want it to be deliberately weird.
Okay, got it. A bit of fun to show customization. All right, next up, agents. These sound more advanced.
They definitely are. Agents are like LLMs that can reason and use tools.
Tools, like what kind of tools?
Like accessing Google search or calculators, or querying a database, or hitting an API. They figure out what tool they need based on your question.
Whoa, so if you ask it something its training data doesn't cover...
It can go look it up. The example is asking, what is the capital of Canada? The agent realized it needed to search, used the search tool, and got the answer.
Okay, that is a leap. It's proactive. What about interacting with APIs directly? That seems vital.
Absolutely. LangChain makes it much easier to use natural language to talk to APIs. Instead of writing code to hit an API endpoint, you can just ask a question.
Like the REST country's API example, asking about France in plain English.
Exactly that, yeah. It figures out how to make the right API call based on your natural language query. Huge time saver, potentially.
I can see that. Developers would love that, and understanding code like GitHub Copilot.
Similar idea, yeah. LangChain can analyze code bases. The example used FAIS and Retrieval QA. Basically, ways to find relevant code snippets. You could ask how do I find the closest match in a list? And it might point you to the process.extract tone function from the fuzz library.
Like an AI pair programmer that understands your specific code. Very cool. Okay, querying tabular data, spreadsheets, databases.
Yep, you can ask questions in natural language about structured data. They use the San Francisco trees dataset as an example with SQL database chains.
So you could ask how many oak trees are there without writing SQL.
Exactly. LangChain translates your question into the SQL query, runs it, and gives you the answer. Makes data much more accessible.
Definitely. Okay, extraction, pulling specific bits out of text.
Precisely. Finding structured info within unstructured text, like pulling out fruit names and their emojis. Or, more
Mm-hmm.
usefully, extracting an artist and song title from a request using something called response schema.
So it finds and structures the information. Got it? And the last one? Automated scientific literature review. Sounds complex.
Yeah, that was about evaluating the quality of summaries or extracted answers. Yeah. Using the Paul Graham essay again as an example, checking if the generated answer was accurate based on the source text shows potential for quality control.
Okay, that's a really good overview of the what. The article also had that tutorial on building a semantic search engine that seemed to cover the core building
It
blocks.
did, yeah. It laid out the fundamental concepts LangChain uses for retrieving information. You start with the document.
The basic unit of data, text plus metadata.
Exactly. Page content, maybe where it came from, page number, etc. Then you need to get that data in. That's where document loaders come in.
The connectors, like for PDFs, websites.
All sorts. PDFs using PYPD floater, which usually makes one document per page, websites, databases, you name it. They bridge the gap between your raw data and LangChain.
Makes sense. So data's in as documents, then what? You mentioned splitting.
Right. Text splitters. Because LLMs have those context limits, you often need to break down long documents into smaller manageable chunks. Something like recursive character text splitter tries to keep related texts together.
Okay, smaller chunks to feed the LLM. Got it. What's next? Embedding.
Embeddings. This is where you turn the text chunks into numbers, vectors specifically. The idea is that chunks with similar meanings end up close together in this high-dimensional vector space. OpenAI embeddings are a common choice here.
So it's like giving each piece of text a coordinate based on its meaning.
That's a great way to put it. And to search these coordinates efficiently, you use vector stores.
Specialized databases for these vectors.
Exactly. They let you do fast similarity searches, find vectors, and thus text chunks that are close to your query vector. The tutorial used a simple in-memory vector store and showed searching for Nike distribution centers in their 10K report.
Finds the most relevant chunks based on meaning, not just keywords
B.
and retrievers.
Retrievers is sort of a more general concept for fetching data. A vector store retriever is one type that uses a vector store, but the idea is to have a standard way to, well, retrieve relevant documents based on a query.
Okay, this paints a clearer picture of the pipeline. Load, split, embed, store, retrieve, very helpful. Now that Reddit thread, why bother with LangChain when you could just use, say, the OpenAI API directly? What's the real advantage?
Yeah, that's a fair question, and the discussion there hit on some key points. You can go direct, of course, but LangChain adds layers of abstraction and tooling that become really valuable as things get more complex. Exactly.
For what specifically?
Well, a big one is the standard interface. LangChain lets you write code that can work with different LLMs, OpenAI, Hugging Face, Anthropic, whatever, often with minimal changes. Gives you flexibility.
So you're not locked into one provider. That's huge.
Definitely. And then there's the built-in support for more complex workflows. Remember, the agents using tools?
Yeah, the searching, calculating.
Right. If you just use the OpenAI API, you'd have to build all that logic yourself. Figure out when the LLM needs a tool, how to call it, how to feed the result back. LangChain provides frameworks for managing all that.
Okay, it handles the orchestration. What about memory and chatbots?
Same story. LangChain has components specifically for managing conversation history. Doing that robustly from scratch with just the API calls is, well, it's a significant amount of work. LangChain streamlines it.
So simple prompt response. Maybe the direct API is fine, but for anything more involved, agents, tools, memory switching, LMS chain saves a lot of effort.
That's the gist of it, yeah. It provides the scaffolding for more powerful AI applications.
Makes sense. Now, briefly, Airbyte came up. How do they fit into this picture with LangChain?
Airbyte is all about data integration, getting data out of various sources, databases, SaaS apps, files, and into a place where you can use it.
So they help feed the beast, basically, get the data ready for LangChain.
Exactly. Building good LLM often needs good, relevant data. Airbyte simplifies that whole ETL extract transform load process. They even have features aimed at AI workflows, like chunking data and creating embeddings as part of the data pipeline.
Oh, so they can handle some of the prep work before LangChain even sees the data.
Potentially, yes. Things like their connector development kit and PyAirbyte make it easier to get data from anywhere and make it, LLM ready.
And there was that example pipeline, Salesforce Data Airbyte, Dagster, LangChain.
Right. Airbyte pulls from Salesforce, Dagster, a workflow orchestrator, manages the process, loading it into LangChain documents, then it gets split, embedded, put in a vector store, and finally used by a LangChain app for Q&A on the Salesforce data.
A real end-to-end example. Useful to see how it connects. Okay, let's circle back to document loaders. We mentioned them, but the LangChain docs, probably Gooper, they seem pretty fundamental.
Absolutely crucial. They are the entry point for almost all data. The key thing is they load data from tons of sources into that standard document object we talked about, text content and metadata.
hmm
And the main method is always .load. Simple.
And the range of sources is wide.
Incredibly wide. For web content, you've got basic web page loaders, web-based loaders, ones that try to pull main content unstructured, recursive loaders for whole sites,
hmm
recursive URL, sitemap loaders, even Playwright for sites that need JavaScript.
Okay, covers the web well. What about files? PDFs seem common.
Loads of PDF options. PYPD floater, unstructured PDF loader for cleaner text extraction, even specialized ones like MathPix PDF loader for PDFs with equations.
Math equations. Wow, okay. Cloud storage, S3, Google Drive.
Yep. AWS S3, Azure Blob Storage, Google Cloud Storage, Google Drive, all covered. Plus social platforms like Twitter, Reddit, messaging apps like Telegram, WhatsApp, Discord,
Productivity tools too. Notion, Slack.
Notion, Slack, GitHub.
Mm.
The list goes on. And standard files, of course, CSV, JSON, HTML, Markdown. Basically, if you have data somewhere, there's a decent chance LangChain has a loader for it.
That really lowers the barrier to entry, doesn't it? You don't have to spend ages writing custom ingestion code for every little thing.
Exactly. It lets you focus more on the actual LLM application logic, which is, the fun part.
Okay, we have covered a lot of ground here. Let's try and distill the key takeaways for someone trying to quickly understand LangChain.
I'd say the main things are, LangChain is a framework to build more complex applications on top of LLMs. It's modular. It helps manage things like tools, agents, and memory, which are hard to do manually.
And it's flexible, right? Works with different LLMs, connects to almost any data source, thanks to those extensive document loaders.
Definitely. That flexibility and the pre-built components for common patterns are its big selling points over just hitting an API directly. It accelerates development for sophisticated AI tasks.
Okay, so as we wrap up, what's a final thought or question we can leave our listener with based on all this?
Maybe think about one specific information-heavy task you do regularly. Could be summarizing reports, answering common questions from documentation, pulling specific data points out of emails. With what you know now about LangChain's capabilities, summarization, Q&A extraction, agents could automate or significantly improve that task. How might you use it to get insights from your data faster? It's worth pondering.